Good to see you guys back here at David Moore Engineering. So today is an exciting day for us. Our crank balancing equipment has just turned up. John from Surrey UK, who supplied the machine from America, has basically come down, brought it down. Do you guys want to come over, check? So we're going to go through, try and unbox some bits. So we've got brand new bob weights for V8 cranks and V6 cranks. And then over here, we have the machine. So we have gone, you can see John's clearly unpacked it and then brought it down. He's obviously done his due diligence and checked it out before bringing it to us. So we've gone for a milling machine mounted balancer. It's the same balancing machine that we've been using, but we've been going over and using someone else's machine for the past few years. So we wanted to take this time to share this with you guys, get it unboxed. So we're going to get this unboxed, set up, and we're going to try to get a crank balanced today with you guys. So now that we've got everything mounted up, it took a little bit of time off of the camera because me and Ross had to re-drill a bracket. Obviously, this is designed clearly for a smaller milling machine than this is. So like we said, we've been using this, this exact same machine, but in a standalone machine. We was lucky enough to be able to borrow that machine for a couple of years in order to sort of help us build the business. So what we're going to do, turn it on for the first time. Me and Ross have set this up so that we can sort of go through this. And basically this is your calibration arbor. So how the machine works, you have a motor and a belt, turn it, 2 sensors and an encoder. So that encoder should tell us where the crankshaft is, how fast the crankshaft is spinning, or the test piece currently here, and then the encoders will read 2 measurements. So now when you're onto the computer, And one of the things we want to do here is we're going to build a nice bench over in this area. We're going to have to move that cupboard so that the screen will stay in place full time, and we only have to lift the measuring equipment on and off, so we can still use the milling machine as a milling machine if we need to. But just due to the amount of space we have here, this is something we've had to work with for now. So what we're going to do, guys, is get a tape measure out. And basically you just have some bits to go through. So look, we're looking at about, I don't know, 7.5 inches apart. So if we clear that and we go 7.5 inches, I'm really hoping all of this worked perfect first time. Now I'm gonna guess that the Americans rather nicely have put those, so roughly we're talking about a 3-inch radius, but where they're looking to put the bolt holes in this, I'm looking is about the 2-inch mark. So if we leave this, I'm guessing that's why it's set, because they would have calibrated this machine for us before they sort of sent it to us. That's what we're hoping. So how this all should work is this should turn it on, speed control here, and then we can click measure. Now, if you guys look, because this is a calibration unit, right, you have the ability to bolt weights in. So what we're going to be doing is we should see some imbalance. So if we now switch that on, so you can see here, we've got a clear RPM reading. So, and we can speed that up and change that. So, and look, the machine is automatically gone to measure, and we're seeing 46.29 and 43.03 grams of imbalance. So, but realistically, I'm thinking we're going to want to look at the single plane because we're bang in the middle. So what we'll do, we'll turn that off. I'm now going to pull these out, and on paper, that arbor should be perfectly true. So guys, you can see we've now pulled these weights off. What we're going to do, just spin this marker up now, and she should automatically, there we go. And so you can see clearly that the machine is calibrated, and that calibration mandrel is spinning perfectly in balance. So now what we're going to do, we're going to get the scales upstairs and measure the amount of weight we have here, put it back in and see what we find. Do you guys want to come upstairs? So now we're upstairs in the build room and we've got the scales set up. You can see that on both sides, we've got 45.88 and we've got 45.85 grams. So now what we're going to do, we're going to take these back downstairs, put these into the mandrel, and then see what imbalance the machine is reading. So come on down. Right, now we're back down in the workshop. We've now bolted those two weights in. So what was it? It was 45.88. You can see here we've set our offsets into the balancing machine. So if we now spin this up and hit measure, what we should be seeing is that. So we're getting 52.16 and 34.79 and 86.91. So that, to me, would say that we need to run a calibration. So what we're going to have to do, we're going to have to explain to it how much weight we're putting on this and where we're putting the weight so that it can then understand what force X weight situates into these sensors so that it's calibrated for when we put crankshafts onto it. So we're going to go through all of that and then we'll come back to you guys. So let me show you guys quickly. So we've now gone through run a calibration where you basically run the machine, you go to where the weight is, you then tell the machine exactly how much weight you've put in. And you can see now, so we're now getting 92, okay, let's run it again. 91.98, so we're perhaps 0.01 of a gram out over where we should be. And from previous experience, what I have found is the closer you get to 0, the better that will be, because obviously the more weight you have, the more force it's throwing around. So the other thing as well, if you look here, we've got slightly different measurements here and here, but that's because you're taking both of the weights. And so it's both trying to calculate that it's far from the middle. Once you start getting a crankshaft where you're taking the weight from exactly where it's measuring, they should become closer in due time. Now, one of the important things for us whenever we use the crank balancer is to always check the calibration each time, because this is a machine that we're going to have to take on and off the mill. We'll always go through check calibration. So shall we have a play with it now and just see a little bit of whether or not it's able to pick up some measurements around, basically. So hopefully now what is going to happen, if we take that off, we should be able to spin that up and she should read perfect. Okay, so yeah, we're reading 0.74 of a gram, 1.52, so yeah, and they're just not moving. So it's repeating every time on what it wants. So I want to show you guys something. Obviously, me and Ross quickly, we've just popped the crank up, run a quick check, make sure that everything's okay. We just want to show you how it works so that you guys can get an understanding. This is obviously a bit of a new toy to us, so we're going to be playing with this. So one thing we do have to do, your magnet here, that needs clocking in, but we're going to do multiple different setups, so for direct bolts into cranks and stuff like that, so that we don't have to worry about that, and it will be a lot more fixed and a lot more balanced. So we need to roughly 14.5 inches, so we're going to go with 14.5 inches. And then what we're going to do, left radius, so we're looking at about 2.25 inches, 2.25 inches. Right radius is going to be a 2.25 inches. We'll get there in the end. 2.25, right offset. So again, we're going to be coming into the machine about 1.5 inches and about 1 inch this end. So we're going to go 1.5. And then backspace 1. And then left radius is more like a 1 inch. And we're going to hit that. And then that is obviously going to be a 2. We probably need to pull this plastic off. 2.25 inches for the whole crank. So on paper now, everything seems to be okay. And what we're going to do, we're going to set big end number 1 up on, and we're going to then hit set 0 on the machine. So let's run that through. We're spinning at 600, it's automatically measuring, and this crank is in balance, which is good because the customer was supplied this crank and was told it had been balanced. So this is good news for our customer. So, right, as we saw, this crank is in balance. If we look down here, the imbalance tolerance is actually a bit higher than what we'd like. So we're probably going to change the tolerance settings in the machine. And I'm going to stay and go through and drill this. Unfortunately, Ross has got to get back home tonight. So I'm going to stay, try and get this finished up for the customer. And what I would like to ask of you guys can like and subscribe, and we'll see you next week.